And of course, there are like a lot of other ways. As I said, you can learn these upsampling layers, and you can say like you can have deconvolution layer, and these three are just some variations how you can do. For example, if you have to go from 2x2 to 4x4, this is another interesting way. You can just perform zero padding. Okay, and when you perform zero padding, so this is your window size, and it's computing like, so stride is 1, window size is 3x3, and that kernel is just performing the transformation at each location, and that is going to give you 4x4. One thing is like for most of the values, 0 will be used, but still there is some learning being performed here. Similarly, you can have this kind of variation, and I think what's happening here is, this is a variant which we discussed earlier. For each location, you can actually have multiple kernels. Okay, and you can just place those values which are getting from multiple kernels at different locations of the upsampling output. Now, another variant of the center method here is you can actually insert stride into your activation maps, something like this. Okay, and then again perform the same operation. And then again you will get, in this case, let's say you're getting 5x5. Okay, so again, these are some variations how you can perform upsampling. And some of these have like their own advantages, which is fine. We don't have to go in that direction. Okay, so basically, as I said, you can use like a simple convolutional based autoencoder to perform semantic segmentation. And this is just one variation of that, where given an input image, you can have your the classification network, or you can say like the encoder convolutional network, where you can have convolution layers, max pooling layers, and at the end you have these flattened features, and then you can just repeat like all these operations in the reverse. Okay, and what you will need is like you will need some kind of uppooling or upsampling. And again, as we discussed, like there are a lot of ways you can perform this upsampling operation. You can actually use the indices of max pooling to do that. And again, these can be your simple convolution operations in between. So you have unpooling or upsampling, convolution operation, upsampling, convolution operation. And some variant of this, I think you already did in one of the assignment when you were implementing autoencoders. Now, like these are some sample results like from this kind of architecture. And here you can see that the resolution of the output actually will change a lot depending upon where you are actually predicting the segmentation map. And of course, you can just predict at the end, or you can predict like after each layer as well, right? So this is just showing that. And you can see like as you increase the resolution of your upsampling activation maps, the quality of result is going to be better and better. Okay, so these are kind of fragmented, but still you have some kind of structure, and you can say that this seems like a bicycle, but you don't have the fine boundary because you don't have that high resolution here. Right? So it will keep improving, and this looks pretty good, right? You can say this is a bicycle easily.